Hi, I'm Mark Barsamian. In this video, I'll be discussing derivatives of quotients. This material is from section 3.3, derivatives of products and quotients. We covered products in previous videos. More specifically, the readings from the middle of page 198 to the top of page 201, examples 4, part A and B, and 5. The homework is this collection of 4 problems from section 3.3. Now recall, before going on, the derivative rules that we've learned about in previous videos. The early rules, the constant function rule, the power rule, the sum and constant multiple rule. The rules we learned about at the beginning of chapter 3, the exponential function rules and the log function rules. And then the rule that we learned about earlier in this chapter, the product rule. Today we'll learn about the quotient rule. So consider a quotient of functions. That is a function f that's written this way. A ratio with a function on top called top and a function on bottom called bottom. And the question is, how is f prime related to top prime and bottom prime? Well, the good news is there's an obvious relationship. The bad news is that the obvious relationship is wrong. So here's the obvious relationship. So there's the obvious relationship. The derivative of a ratio would just be the ratio of the derivatives. That's what you would guess. But this is wrong. How do we know it's wrong? Well, consider this easy example. Let f of x be this function. So let's find f prime using our established derivative rules. Well, that will involve first rewriting the function. So recognize that x squared divided by 5 is the same as 1/5 times x squared. So now we can find f prime using our very basic rules. So we get an answer that f prime of x equals 2x over 5. The important thing is that we used the constant multiple rule to deal with this 1/5. That's a constant multiple, so it slipped right through the derivative symbol. We took the derivative of x squared just using the power rule with n equals 2. The left side of the power rule has d dx of x squared. The right side of the power rule says 2x to the 1. And we simplify it and we get just the answer 2x over 5. Now let's try computing f prime using the obvious bad method. So I'm going to do this in red because it's so bad. So look, when we do the obvious thing, the derivative of a quotient is the quotient of the derivatives, we end up with an answer that does not exist. This is wrong. What's wrong about it is this step. It's not true that the derivative of a quotient is the quotient of the derivatives. So the obvious way is wrong. It leads to the wrong answer. So the correct relationship between f prime of x and top prime and bottom prime is given by this complicated rule called the quotient rule, used for finding the derivative of a quotient of functions. The rule says if you have a function f of x that's of that form, top divided by bottom, then its derivative is given by this messy formula. F prime is equal to top prime times bottom minus top times bottom prime, all over bottom squared. Written on a single line, the quotient rule looks like that. d dx of a quotient is equal to this messy thing. So let's revisit our function from example 1, f of x equals x squared over 5, and find the derivative using the quotient rule. There's a typo here. Well, we've got the quotient rule on the previous page. I'm going to copy it down here. So there's our form. So let's apply that form to this problem. So there's our form. Now we have to do the derivatives. That is, the quotient rule doesn't tell us what these derivatives are going to be. It just says that they're the derivatives that we're going to do in the next step. So let's do the next step. I'm going to start by copying down all the stuff that doesn't change. So there we have space for those derivatives. The derivative over here is going to be done by the power rule. The derivative over here on the right is going to be done by the constant function rule. The derivative of a constant function is 0. Well, look, that kills that whole term. That whole term is going to be 0. So I end up with 2x times 5 over 25. But we should simplify. So our answer is the derivative is 2x over 5, which is what we found earlier. Hey, look, using our established derivative rules, we did that derivative in one line. Using the quotient rule, we took all this space, a lot more writing, a lot more chance for mistake. So the takeaway from that is when you can use more simple rules, when you can rewrite the function, do that. Remember what we did in example 1. We used easier derivative rules, but the reason we were able to do that was that we had written the function f of x in a simpler form. We rewrote the function into a form where we could use the simpler derivative rules. So the takeaway from this example number 2 is, well, there are two takeaways. One is that the quotient rule does give the right answer, but the second takeaway is that, wow, the quotient rule is a mess, and if you can avoid it, try to avoid it. Okay, example 3, this is similar to 3.3, number 25. F of x is this quotient. Find f prime. Remember our form. We take the derivative of the top times the bottom minus the top times the derivative of the bottom divided by bottom squared. Now we go to the next line to actually do these derivatives. I can't stress enough the importance of writing down the form in the first step. Don't do those derivatives that are indicated until the next step. So we'll write down all the stuff that doesn't change. And then we'll put the derivatives in these empty parentheses. So those two derivatives I won't go through the details of, because now that we're getting into harder derivative rules, we need to start streamlining our solutions, and I will no longer keep going through all of the individual steps. Now, how can we clean this up? You might notice that there's an x squared minus 3 in the numerator, and there's some factors of x squared minus 3 in the denominator. You might think you can cancel those, but you can't, because that factor, x squared minus 3, is not a factor in the whole numerator. There's no x squared minus 3 over here on the right. So we cannot cancel x squared minus 3. That's such an important thing to make a note of that I'm going to write it in red. All right, well, so how can we clean this up? Well, we just have to simplify by doing the arithmetic that's specified in the numerator. Now you have to be careful with these signs. Notice that I distributed those terms first, and I left the results in big parentheses. And there's still a minus sign in the middle. Now let's deal with that. Let's do the arithmetic in the numerator the rest of the way. And there's our result. F prime of x is this messy expression. Let's go on to the next example. Example 4 is similar to 3.3, number 31. F of x is this quotient. We're supposed to find f prime and simplify. Well, we'll set up the quotient rule and do the details. So there's the form of the quotient rule. And I did not do those derivatives that will happen in the next step. I saved them for a separate step. The quotient rule is just setting this up. Now, in the next step, we'll do those derivatives. And I take my usual approach of starting by copying down the frame. Now we fill in those empty parentheses with the results of those derivatives. So the left derivative we computed using the exponential function rule, and the derivative on the right we computed using our earlier rules from chapter 2. Now we simplify. Now, how can we simplify this? You might think that we'll have to do like we did in the previous example, where we multiplied everything out in the numerator. Remember that we did this step where we used the distributive property to distribute this 3 and to distribute this 2x. But look at this numerator. Notice that this numerator has a left expression and a right expression, and both of them contain an e to the x. So when you see something like that, it's important to realize that you can simplify this expression by factoring out that e to the x. The way that will look is the following. We'll make room on the left for that term. And then we put a pair of parentheses for all the stuff that was left behind. Well, the stuff that was left behind is this stuff, x squared minus 3 in parentheses, and this stuff, 2x in parentheses, with the minus sign out front. So again, the approach to factoring is to clearly identify the thing that you're going to factor out, underline it, and then move it out and show parentheses with what was left behind. Now we have a denominator we've got to remember. So we can clean this up a little bit. Notice earlier there is a step here where you might think that we could cancel an x squared minus 3. But that's just like the previous problem, where I said we could not cancel the x squared minus 3 because it was not a common factor. So I should have mentioned that. So we cannot cancel the x squared minus 3 at that point. And there's our result. Our derivative is that messy quotient. Let's go on. Example 5 is similar to 3.3, number 33. The function is this ugly quotient. All right, we'll find f prime by setting up the quotient rule. So there's the form of the quotient rule. We have the derivative of the top times the bottom minus the top times the derivative of the bottom, all divided by bottom squared. And let's note what I always note at this step, that you cannot cancel those factors. Because again, that factor appears in the denominator and it appears in this part of the numerator, but it does not appear over here. It's not a common factor in the whole numerator. All right, now in the next step we're going to do those derivatives, but let's copy down all the stuff that doesn't change. Now let's compute these derivatives. Remember that the derivative of ln of x is 1 over x. And remember that that rule does not tell us that ln of x is 1 over x. It tells us that the derivative of ln of x is 1 over x. So we replaced this whole expression, d dx of ln of x, with this expression, 1 over x. Over here on the right, we have a basic derivative, so I'll just write the result. Now we have to simplify. How can we simplify this? Well, one good rule of thumb for simplifying is that you should not have fractions over fractions. You should have a single baseline in your equation. Our equation has two baselines. It has this big horizontal line, and there's another horizontal line in that fraction. So it would be good to eliminate the second baseline. How can we do that? Well, we can't pull this 1 over x out front because that 1 over x is not a common factor on the left and right sides in the numerator. So I'm going to do a trick here. I'm going to copy this whole expression and move it down. Okay, so I've copied that whole expression. Now I'm going to do something. For this upper right term, I'm going to multiply and divide by x. The reason I did that is because that way then both of my terms in the numerator have a 1 over x. So I can bring that 1 over x out front. Now when I bring out that 1 over x, I have to put a big pair of parentheses for all the stuff that gets left behind. All the stuff in the numerator gets left behind. So on the left there's an x squared minus 3x plus 5. And on the right there's this stuff. So we factored out that green 1 over x. I should have left this x as green to make it clear what we did. Now we still have a denominator. Now finally I have a 1 over x in front of this numerator, and so that x in that front term can be moved down. So you see that this 1 over x became just an x in the denominator. Instead of multiplying by 1 over x, we're dividing by x. And this little x got distributed, creating this term. And so there's a fraction with a single baseline, a single horizontal line right through the middle. It's not a fraction divided by a fraction. It sure is ugly, though. You have a similar homework problem that's hard. It's of this type, but it's not quite so bad because the expression in the denominator is not quite so ugly. So you don't have quite as messy a problem, but you will still have the same basic structure. So there's the answer. Let's go on. Example 6. This is similar to 3.3, number 69. F of x is this quotient. Find f prime and simplify. That's question A. So there's the form of the quotient rule. And it's worth noting that we might be tempted to cancel, but we cannot cancel the x squared plus 4. We have to go on. In the next step, we'll do those derivatives. We'll start by writing down all the stuff that doesn't change. So the derivative on the left is the derivative of x, so that's just the number 1. The derivative on the right is the derivative of x squared plus 4. The derivative will be 2x. Now we simplify. Now this can be simplified further. Notice that we have an expression, x squared, and then we have minus 2 of the same expression there. So together those give us minus 1 x squares. And there's our result. We have to be careful to write this clearly. That minus sign is only attached to that x squared. Now that's question A. Question B. Find the x values where f prime equals 0. Well, let's get our formula for f prime and bring it down here. So f prime of x is that messy expression. Now we're supposed to find the x values that will cause that to be 0. So we have to set this equal to 0. Now how can we solve this? Well, we have a fraction. And remember that a fraction can only be 0 when the numerator is 0 and the denominator is not 0. If we have a ratio a over b, the only time that that equals 0 is when we have a 0 in the numerator and we don't have a 0 in the denominator. Well, so let's start by finding the values of x that cause the numerator to be 0. So we end up with two values of x that cause the numerator to be 0. Now we have to double check to make sure that the denominator is not 0. Notice my calculations. You have to be careful about the signs. When you substitute in x equals minus 2, you have to put it in parentheses and square it. The minus gets killed by the squaring. You end up with just the number 4. And then notice that I did not actually bother getting a final answer for that number. That would not be that hard. 4 plus 4 is 8. 8 squared is 64. But the thing is, we just wanted to know if that number was going to be 0. And we see that inside of parentheses is a number that's not 0. So when I square it, I'll get a number that's not 0. The conclusion of this is that those two x values here are x values where the numerator is 0 and the denominator is not 0. So those are the x values where f prime equals 0. Let's write a conclusion about that. So f prime of x is equal to 0 at those two x values because the numerator is 0 and the denominator is not 0 there. That's the answer to question B. Question C is illustrate our results of B on the given graph of the function f of x equals x squared plus 4. Well, what is our result from question B? Our question B was this. The derivative is equal to 0 at x equals 2 and x equals negative 2. Well, so what does that have to do with the graph? Remember that the number that's the value of the derivative is equal to the number that's the slope of the tangent line. So this result tells us that on the graph of f of x, the tangent lines at x equals 2 and x equals minus 2 are going to have a slope that's the number 0. That means they're going to be horizontal. So again, the symbol f prime parentheses 2, we've determined that has the value 0. That is the slope of the tangent line at the place on the graph where x equals minus 2. And this symbol, f prime parentheses 2 equals 0. We got that in question B. In terms of the graph, we recognize that that's the slope of the tangent line at the place where x equals 2. So that's how we illustrate those results on the graph. Well, that's the end of that example, and that's the end of the video. Thank you.